In example number 1, we discuss on how to sketch the cubic functions in the form of ax plus h power of 3 plus k. Now, in example number 2, instead of having the cubic function written in this form here, let us discuss on the case of cubic function that we can completely factorize into 3 linear factors. And along in these examples here, we try to follow back the idea, the simple steps in graphing to do the sketching here. Just that later in step 2, the shape of the graph will be slightly different from what we have in the example 1. Okay. Anyway, step 1 is done. We have it identified, can be completely factorized into 3 linear factors. Now we go to step 2. We want to identify the shape of the graph. So the shape of the graph that we have is that we're still referring to the coefficient for x cubed. And in the diagram here, you can see that we have the shape of the graph for positive coefficient for x cubed and negative coefficients for x cubed. And how we remember this shape here is that it as if like the combinations of two parabolic curve in quadratics, where for the case that we have positive, as if like we are someone that happens to be positive thinking. Whenever we have sad thing, eventually it will turn into something that is happy. So sad to smiling face. Negative, as if like we have negative thinking, whenever, even though it's something that's supposed to be happy, having smiling face, but it turned out to be sad. Okay. So go on. Back to our examples here. To identify the coefficient for x cubed here, the quick way to do so is that we just refer to all the x term that we have. We multiply it like what I happen to do in this slide here. Then I find out that the coefficient is negative 2, which is less than 0. Therefore, in this case here, we have the case of negative coefficient for x cubed. So the shape of the graph will be this one, from smiling face to sad face. Then the next thing, step 3, we're going to identify the special point here. In here, the special points that we refer, of course, there is an inflection point here, but the inflection point is not so significant in the graph here. The one that is more significant for us to refer, suppose in this case here, will be the maximum and also the minimum point. In order to get the coordinate of the maximum and minimum point, we can use by using differentiation to obtain the answer. However, it's not being emphasized in this chapter here now. If later you enter chapter 9, we are able to identify the maximum minimum point and even the shape of the graph by using what we call as the first derivative test. But once again, it's not emphasized here. So just for information, the remark here, I already pre-calculate the maximum and minimum point with these coordinates. And next, what we want to do is just that we will go on with the calculations on the x and y intercept. So by right, if you're able to identify that you can factorize into 3 linear factors, so automatically we somehow know that there should exist x-intercept, and of course the y-intercept, by right it will happen to exist as well for this type of functions. So let's see, to do the calculation for y-intercept, again we take the functions where x equal to 0, so we find out that we have the answer fx equals to negative 2, so the y-intercept is negative 2. Whereas for the x-intercept, we have fx equals to 0, and from fx equals to 0, we have the x value as negative 1 over 2, 1 and also 2, and these 3 value will be the x-intercept. So once I can get the answer for the xy and xy intercept, now let us go for the graph sketching, guys and girls. So the last step, the graph sketching, let's see. You notice that in the graph sketching here, on the Cartesian plane, I have get ready with the marking of the xy intercept. And then now I'm going to insert the graph. Just now I identify that the shape of the graph looks something like this. And by right, from step 4, I noticed that I have 3 x-intercept. So by right, this is what happens in my drawing. And as a result now, there goes the graph that I should have. So this is the graph that I should have. And by right, we should label the maximum and minimum point. However, since the calculations is actually learned in chapter 9 differentiation later, so I will just leave it the graph in this form here without labeling the maximum and minimum point. So go on. Remember, in this diagram here, you need to do some labeling. So you need to label the xy intercept, the origin, the name of the graph, and also the xy intercept.